proportional to the number of quantization levels. So levels is inversely proportional to error here. Okay, so we have some digital levels after the quantization. These are the two phenomena used for converting analog data to digital data. Now what we can do to convert digital data to analog data, for that we have many mechanisms, but the important one is the R2R ladder. R2R ladder uses a mechanism of parallel resistances. What is a parallel resistances mechanism? Let's say we are having two resistances which are in parallel, and we supply some voltage here. So let's say this one is R2R and this one is 2R. So if we take the parallel of this resistance, this side is ground. So the parallel of 2R is 1 over R naught is equal to 1 over 2R plus 1 over 2R, and this becomes 2R plus 2R divided by 2R, which is 4R divided by if this one is 2R and this one is 2R, then the resistance will be R divided by 2R, R plus R divided by 2R. The LCM is 2R, so this 2R divided by 2R gives us an R. Okay, so this is 2R by 2R, which is R, which is obvious because the parallel of two resistances which are similar, let's say R and R, is R by 2. So if this is 2R 2R, then this is 2R by 2, which is R. Let me remove these things from here. Okay. So this mechanism is pretty much easier. So if we have a voltage signal in here, let's say there is a voltage V here, and here we have 0 volt or floating, and this one is floating and this one is floating. So let's consider this one as 1. So we are going from digital to analog. So this is the B naught, which is the least significant bit, and this is the most significant bit. So what makes it least significant bit is the traveling through these R's. So this 1 volt will be dropped R, and this parallel combination of R. So this will be dropped 4 times more than this most significant bit. So this will make this B naught as B naught by 16. Similarly, this B1 will be B1 by 8, and this B2 will be by 4, and this B3 will be by 2. So if we add up these three things, it will be approximately equal to V. A bit lesser than V, but almost closer to V. So this is the R2R concept, that if this thing is floating, then there will be no this resistance. There will be no resistance shown in here. If we have this thing floating, then this point will be not considered. If this thing is floating, this will be not considered. But if these things are present, then this R will combine with this R, and this is actually equal. This thing can be written as R and R. So everything is RR. This will become RR because this thing will make this 2R as R. Everything is in parallel with 2R. So this is the concept of this ladder, that if we have, let's say, 1 0 0 0, this means that B3 is 1 and B0 is 0. This is the most significant bit. So 1 and 0 0 0. This 1 can be represented by a fixed voltage, let's say 5 volts, so 5 volt and 0 0 0. Similarly, if we have 1 0 0 1, this will mean that B3 is 5 volt and B0 is 5 volt, and these two are 0, and then these all voltages are added to get this output voltage. So this is the digital to analog conversion. You can read more about this on this site that I have given. Now let's discuss the function generator. Function generators are actually the devices that are used for generating some waveform. So waveform can be of three types: the square wave, the triangular wave, and sine wave. So first of all, we have some frequency control circuit in which we control the frequency so that the waveform's frequency can be generated. This frequency controlled circuit is organizing this fixed constant current source to get in more than one frequencies. So frequencies change from here, and from here we generate a waveform. If the waveform is generated and this waveform is compared with some, let's say, threshold. So let's say if this is greater than 0, then put it a 1, and if this is less than 0, then put it a -1. So this will give us something like this. So this gives us this wave, which is used like this and so on. If we have such circuit and we integrate it, so the integration of our, let's say we are having this voltage as 1 for time t. So from 0 to t we are having 1. So if we integrate this thing, this will make this thing as t divided by 1. So what this t means, if we put t equal to 0, we will have a 0 value. If we put this t equal to 1, we will have a 1 value. So this is something like this. Similarly, a minus t will have a negative slope, so something like this. So if we use an integrator circuit with the same chopped wave, we will get something like this, which is this one output. And if we just directly use this frequency, it will be this output. So we do not use it directly. Instead, we use the shaper circuit. What is a shaper circuit? If we have a wave like this and we pass it through a low pass filter, so low pass filter will remove these edges from it, and this wave will become this. So this is the shaping circuits. So this is the function generator. It can use three types of outputs, and it uses a frequency control network which produce frequency. These frequency control networks are known as the oscillators, which will be studied later on. Okay, coming towards the another instrument, the cathode ray tube based oscilloscope. In this instrument we are having two plates, the horizontal plate and the vertical plates. So we are having an electronic beam. Normally there is an excited coil which produces electrons, and this electrons travels towards this screen, this fluorescent screen, and these electrons are diverted by two mechanisms called vertical plates and horizontal plate. So let's say we are having an input wave like this on this side. So if this same voltage is given to these horizontal plates, if this voltage is given to this vertical plates, what will happen? With increase in this voltage, the electrons that are going from this point, these electrons are not in the control of this voltage. These electrons will just be produced by some source. So these electrons are produced, and this signal is provided to the vertical plate, and if the signal is high, the electrons are moved towards one side of this screen, and if the signal is low, these electrons are moved towards the other side of the screen. So a vertical plate means that these are something like this, and if an electron goes through this and we provide a voltage toward this, then it will move toward this side, and if the voltage is more on this plate, then it will move towards this side. So this is about the vertical plate. The horizontal plates, which are something like this, will move the electron up and down. So vertical will move electrons left and right, and horizontal will move these electrons up and down. Remember these two phenomena. Now let's create another slide in it and understand the whole process of moving the electron beam for creating an image. So let's say we are having this screen and we are having this wave. So first, this wave is given to the horizontal plates. So horizontal plate, when the voltage will go on this side, this plate will have more charge. So it is given to this, so this will have more charge. When the electrons, when the voltage is, the wave is on the negative side, then we will have more charge on this plate. So this will move these electrons to go up, and this will move this electron to go down. So we will have a beam of electrons here, and this beam will move up and down. So we are having an up and down beam. Now what we do, we provide a ramp voltage to the vertical plate. So we are having two vertical plate, and we pass the same electron beam through this vertical plate. So vertical plate with this ramp will move an electron, will move this graph on this side. So it was initially moving like this, and now it will move like this because it is pushed on this side. So the more is the ramp, the more it will go on this side. This ramp is repeated again and again, and this motion is, this whole cycle is covered in this one ramp. So if this whole cycle is covered in this one ramp, we will have a wave like this. So a wave was moving like this with the horizontal plate, and with the introduction of vertical plate, this wave will move like this. So vertical plates makes it move towards the right side. Okay, so this is the phenomena of producing this waveform. Any waveform can be produced by the input signal. So input signal, where whatever it is, we will have the image of this thing on this screen. We use some probes for getting out input voltage to this cathode ray tube. So these probes are then connected with these two plates, and then these probes gives us some meaningful results from the input signal. Coming towards the last topic of this introductory session, the oscillators. So oscillators are the circuits which produces this frequency controlled signals, and these are sine waves normally. So sine waves are produced by oscillators, and by selecting values of capacitor, inductor and resistor, we get different values of these frequencies. So the circuits here, this thing is actually an oscillator. Okay, so there are many types of oscillators, but some of them are described here, written here. Colpit oscillator has a circuit in which there is one inductor and two capacitor, and there is a grounded side on this side. So this is C1, C2, and the frequency of this circuit is F is equal to 1 over 2 pi under root L CT, whereas CT can be calculated from this parallel combination of 1 over C1 and 1 over C2. Hartley oscillator uses a circuit like such, in which the inductor are divided into two, and this is, let's say, L1 L2, and F is equal to 1 over 2 pi under root LTC, where LT is equal to L1 plus L2. Okay, the RC phase shift oscillator uses 3 capacitors circuit, and each capacitor gives a 60-degree phase shift. So a total of 180-degree phase shift to the wave is produced by the end of this side, and this wave is again fed in a feedback to this circuit. So this is just a concept. Just go through this link and you will understand more. So RC oscillators are using only the resistance and capacitance circuit. So this is, I guess, inverted. Capacitors are here and resistors are here. So you just check these things. Okay, crystal oscillators use a crystal. So we are having a crystal, and this crystal is in parallel with either capacitor or some other electronic instrument, and it gives us a constant frequency. Wind bridge oscillators uses a series parallel combination of RC, and this bridge is used for generation of frequency. So wind bridge oscillator is something like such. So I hope you have understood these all basic things with the digital and analog instrumentation, and I guess this is it. Okay, thank you. Thanks a lot.